What's up, guys? All right, so today we're going to be doing some function operations, okay? Very first thing we're going to be doing is adding and subtracting functions. All right, so go ahead and get that copied down. One of the things that we're going to do while we're dealing with these functions, the operations like adding and subtracting, multiplying, dividing, and also composing functions, which I'll get to. We're also going to be talking about the domain, okay? And so one thing I want to remind you guys about for domain is anytime you're talking about the domain, you have to remember two things. Really, that's all you got to do, two things, okay? Two things to look for. There's two hot spots, okay? The first hot spot is if you have an even root, okay, like this square root, okay? Remember, you cannot take the square root of a negative number, can you? Okay? All right, so you have to make sure that whatever value of x you plug into that square root, if it's just an x, you can't have negative values of x. But if you have something like an x minus 2 or something like that, you're going to have to solve and make sure you don't end up with negative values after you subtract the 2. It gets kind of weird, but I'll walk you through it if we encounter that. So basically, two hot spots. If there's an even root, you don't want negative values inside your root, okay? So solve for x so that you don't have negative values. And then also, this, denominators, you don't want zeros in your denominator. So if there's an x in the denominator, obviously x can't equal 0. But if there's an x in, like an x plus 2 in the denominator, x can't equal negative 2, that kind of thing, okay? So two hot spots, just remember those. All right, let's go ahead and see what we can do here. The first functions that we're going to add, I'm going to tell you, we're going to let f of x equal 4 times x to the 1/2, okay? And we're going to let g of x equal negative 9x to the 1/2, okay? All right, so let's go ahead and do an example, shall we? All right, functions, when we're adding, subtracting, let's just do subtraction because I think subtraction usually gets tricky. So I'm just going to go, let's do f of x minus g of x, okay? All right, so let's substitute. F of x is 4x to the 1/2, so 4x to the 1/2. All right, and then we're going to subtract g of x. Well, g of x is negative 9x to the 1/2, so we're subtracting negative 9x to the 1/2, okay? And if you work this out right here, negative times that is going to be positive, so we have 4x to the 1/2 plus 9x to the 1/2. All right, and then we can combine them, right? How many square root of x's do I have right there? I have 4. And how many do I have here? I have 9. Notice this is the square root of x, this is the square root of x. Altogether I have 13 of them. I have 13 of the square root of x, or 13 of the x to the power of 1/2. All right, so now I'm gonna ask you for the domain, okay? All right, and the domain, remember, if you look back here, two things, right? Do we have an even root anywhere? Well, let's look. Yeah, we do. We have an even root. It's the square root, okay? All right. Let's look up here. Square root, okay? Actually, I should have looked up here first, okay? So if this is the square root of x, what values of x can we not use? Okay, this is just the square root of x. So you know that x cannot be negative numbers, okay? X cannot be negative numbers, okay? Look here, x to the power of 1/2, that's an even root, so x can't be negative numbers. And finally, look down here, we end up with x to the power of 1/2, that's an even root, x can't be negative numbers. So basically, you can use any value of x that you want, except for negative numbers. And also, let's check denominators. Do we have an x in the denominator anywhere? Nope, 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 okay? All right, so that's adding and subtracting. Let's do multiplying and dividing, all right? So let's do part B. Multiply and divide functions. All right, and in this example, I'm going to let f of x equal 6x and g of x equal x to the 3/4. I'm going to sharpen my pencil. So the very first example we're going to multiply f of x times g of x. So here's our, I just broke my pencil. Example, we're going to multiply f of x times g of x. Okay, so just substitute f of x is 6x, all right, times g of x, which is x to the 3/4, so x to the 3/4, okay? And now we have this times this. We want to add our exponents. So if this is x to the power of 1, that's really 6 times x to the power of 4/4 times x to the power of 3/4. And now you could add the exponents, so you get 7/4. So we have 6 times x to the power of 7/4. Okay, and that's our final answer there. Now let's get back to the domain. Okay, so we want to state the domain. All right, so this is what you're going to do. You're going to look back at f of x and look here. Do I have an even root? No. Do I have a denominator? No. So x can be anything we want right there. Now let's look at this one. Do I have a denominator? No. Do I have an even root? Yes. So x cannot be negative numbers. So right off the bat, I'm going to write x cannot equal negative numbers. Okay. All right. And then finally look down at the final answer. We have an even root. So again, it stays the same. X can't be negative numbers. All right. Let's do another example. Let's do g of x over f of x. G of x divided by f of x. All right. So here we go. G of x, that's x to the 3/4. So we have x to the 3/4 divided by f of x. That's 6x, right? So 6x. All right, let's simplify this. We have, let's see, there's a couple things we, ooh boy, this might get ugly. All right, well, let's see what happens here. I see that this power is smaller than this power, so I'm going to go ahead and bring that guy down. So this is 4/4, okay, I'm going to subtract the 3/4. So now I get 1 over 6 times x to the 1/4, okay. Now keep in mind, we have a radical in the denominator. Let me rewrite this so you could see it. It's 1 over 6 times the 4th root of x, okay. All right, I don't want that. So what I'm going to do is multiply by another 4th root, right, with how many more x's? 1, 2, 3 of them. Okay, and I'm going to do the same thing here. All right, 1, 2, 3 of them. Oh boy. So this isn't really going to... This takes us right back to where we started, doesn't it? Okay, well, whatever. Let's see what happens here. We get in the numerator, we get the 4th root of x cubed, and in the denominator we get 6, and then this turns into just an x. That's exactly what we started with. That's okay though, all right? So let's, that's basically all you can do there. We just kind of went full circle, didn't we? Now let's talk about the domain, okay? All right, the domain is going to be, look here, can x be anything? Yeah, x can be everything. Remember, we're looking for denominators or even roots. We don't have one there, okay? Look here, do we have we have an even root, so x, right? X cannot be negative, okay, numbers. All right, and finally, let's look at our final answer right here, okay? We have a denominator and x is in it, okay? So now x can't be 0, so we also have to list that. X cannot be 0, okay? And there's our domain there. All right, let's do some compositions, all right? Let's do part C, compositions. All right, and again, we're going to let f of x equal 4x to the negative 1. G of x is going to equal 5x minus 2. Do I have an h of x? No, I don't have an h of x in this case. All right, so our first example is going to be f of g of x. All right, now when we find the domain for these guys, it's going to be slightly different, okay? In these problems, we looked at the domain of this one, the domain of this one, and the domain of the final one, okay? We looked in 3 places, 1, 2, and 3, okay? And that helped us figure out what our domain was going to be, okay? When we're adding and subtracting, same thing. We look here, and we look at the final thing, okay? When we're composing, okay, what we're going to do is look at the domain of what is inside and then the domain of what is the final result, okay? That's what we're going to do, okay? So only look in here and the final one, okay? You're not going to look at this one necessarily and this one and the final. You're going to look at just what's inside there. So g of x is inside. So the domain of g of x is just, you could use anything you want, okay? There's no even root and there's no denominator, so we're good to go. All right, so let's go ahead and compose this. So this is how you start off. It's f of this, so we're just going to replace this, okay? So f of 5x minus 2, okay? All right, and now we want to know what f of 5x minus 2 is. Well, remember, f of x is 4 times x to the negative 1. So if it's f of 5x minus 2, it's going to be 4 times 5x minus 2 to the negative 1. Okay, so you put 4 times 5x minus 2 to the negative 1. Okay, so whatever you have here, that's essentially your x. You just replace x with whatever you have. Okay, and let's figure this out. So this turns into 4 over, right? This whole thing is to the negative 1, so this is all going down here, 5x minus 2. Okay, and that's the final answer. So here we go. Let's come up with our domain. All right, the domain, well, again, we look at inside, that's g of x, so x could be anything we want. Down here, our final answer, right, we have a denominator, so solve for x, set it equal to 0. So add the 2, divide by 5, and look, x cannot be 2/5. Okay, that's our domain for that guy. Let's try to squeak in one more, okay? Let's see what we can do here. How about, let's compose f of x. That should be interesting. f of x. All right, so here we go. F of this, so f of x is that. All right, so it's going to be f of whatever that is, 4 times x to the negative 1. Okay. All right, and now we're going to take f of this. Well, remember, f of x is 4 times x to the negative 1. So f of 4x to the negative 1 is going to be 4 times 4x to the negative 1 to the negative 1. Remember, whatever your x is, you're just going to replace that with your x. So it's going to be 4 times 4x to the negative 1 to the negative 1. Okay? You'll get used to it, trust me. All right, and now let's distribute that negative 1 inside. So we have 4 times, this is 4 to the negative 1 times x to the positive 1. Okay, this is 4 times all that, so this goes to the denominator, so it's 4 over 4, and this stays in the numerator. The 4's cancel, and we're just left with x. All right, so let's do our domain. All right, remember the domain is look inside, so what's the domain for that guy? Well, you have a negative 1, so that means the x is really in the denominator, so x can't be 0. All right, x can't be 0. And look at the final answer. This guy is just an x, so x could be anything. Okay, so our domain is just everything except for 0. All real numbers except for 0. All right, that's about it for my time. I will see you guys soon. Peace.